Hello everyone, welcome to the Solidity Fundamentals course. I am Anjali and I'll be your guide for this course. So in today's lesson we are going to talk about the global variables. We've already discussed local and state variables in a previous lesson, and today we are going to discuss about the utility of the global variables, their importance, and we are going to see this by writing a code in Solidity language in the Remix IDE. So what are these global variables? Global variables are nothing but they are special variables that can be used globally in the contract. So this means that global variables are some special keywords, reserved words, keywords and functions which are made available to us by Solidity language, and they can be used through the entire contract, whether inside the function, outside the function, anywhere they can be used, and they need not be declared separately. So these global variables, they give us information regarding the blockchain or the transaction. They are not required to be declared within the contracts and accessible through code. So as we had discussed that the local variables, we needed to declare them inside the functions, right? And the state variables were declared outside the function at the contract level. But in case of global variables, you do not need to write a declaration statement for them. They are available to us directly. You can directly use them. And why are they used? They are used for getting crucial information regarding our blockchain or regarding a transaction or messages. For example, if you want to know your current block number at which this contract has been deployed, or if you want to know the address of the originator of the transaction, or if you want to know the exact timestamp when this contract was deployed, all this information is made available to us by the Solidity language through these global variables. So you need to be aware of the type of global variables available to you, and you can use them to your advantage while writing the code. The important point is that you need not declare it. You cannot actually declare them. They are available to you straightforward, and you can use them inside the function as well as outside the functions. So as I told you, they are useful. They are used for getting useful information regarding the block, the transaction and the messages. So we are going to have a look at some important global variables. The list is huge. We can refer the list at the official Solidity website, and we can try and implement that in the code as well. For today, we are going to see some global variables, and we are going to try to use them in our code. So now let's have a look at some of the important global variables. First is the block hash. It's a global function actually, and it takes block number as its input, and it gives you the hash of the given block. And now there's a condition attached to this global function, and that is that the input block number which you are providing it as an argument, it should be amongst the most recent 256 blocks mined. So if it is older than that, then it will return 0. So Solidity has this rule that it will only show you the block hash of the current amongst the current 256 blocks, not otherwise. Second, block.chain ID. So we know that there are a lot of blockchains available, and again on Ethereum as well, there are a lot of side chains available, or multiple chains available where you can host your contract. So every blockchain is actually given a numerical number which is known as the chain ID, and block.chain ID is the value which returns that chain ID, so that you know that on which blockchain this contract has been deployed. Again, block.coinbase is a very important function, and it tells you about the current block miner's address. So even this information is available to us by Solidity, so that if you want to know that who is the miner of the current block, we just want to know. So you can just write. So there is no need for all these global variables for you to reinvent the wheel and try to, for example, if you want to know the hash value of the block, so there is no way to exactly write the implementation of everything. You just have to use a keyword and the information is available to you. So block.coinbase is again very important. Block.gas limit. It is used to know the current block's gas limit. So many a times, you need to know what is the gas limit of your current block. So you can do so by using this keyword. Block.number will tell you the current block number. Block.timestamp. This is one of the most used global variables. It tells you the current block timestamp as seconds since Unix epoch. So what do you mean by this? So this is basically block.timestamp gives you the current time in Unix time, and Unix time means that the epoch is set to happen on 1st January 1970. So basically Unix timestamp is a numerical value in seconds, and it actually is the value which it represents the number of seconds which have passed since that date, January 1st, 1970. So all that the seconds which have passed, that is it. So there is an epoch converter available, but in Solidity, you always, whenever you deal with timestamps, you deal with Unix timestamps. These are known as Unix timestamps. So you'll always be dealing with Unix timestamps. But there is a lot of utility to this global variable, because a lot many times we need to know what is the current time at which this thing is happening. So in case you are developing a function where you need to get the RSVPs of the guests. So you always need to make a check that whether that event has happened already or it's yet to happen. So how can you do that? You can do that by writing that block.timestamp, which is the current time, should always be less than the event time. So that's how you use this. Again, message.sender is one of the most important global variable. Because it returns you the address of the basically of the account which has deployed this contract. So many a times you want to make the admin the person who has. So if you are writing an NFT minting contract, you are the owner of that contract. You want to be the you want to have all the admin roles to yourself. So you will mark yourself as the owner, and in every case, whenever some functions which are only to be called by the owner, you will always check in the beginning of the function that whether it's I who is basically deploying or calling that function. Otherwise nobody else should be allowed. And how can you do that? By checking that if the current caller of the function is equal to message.sender. So message.sender is actually the person who deployed that contract. Again, message.value is the value which that person sent along with the contract. So in case your contract was payable and it expected you to send some money through the contract transaction, so that money, that amount also has to be matched, whether you send the correct amount, less amount, more amount. So that can be done by accessing the amount which you have paid in this transaction by using the message.value keyword. Finally, transaction.origin, again that will tell you the sender of the transaction, the person who has originated the transaction. So we are going to have a look at all of these, not all but most of these variables through a code, so that you understand them better. So here you can see that I have already written some code for our global variables. So as usual, we have put the license identifier and we have put the Solidity version. Now we have declared a contract. The name of our contract is global variables, and here we have written some public state variables, and we are accessing these values. So I just want to point out here that you will it's seldom that you will use these global variables in this manner. Why? Because these you did not put these values to some other variables, because they are available to us directly. So it doesn't make sense that if you store block.timestamp in timestamp, since you can always call block.timestamp directly. But here, since we have not discussed functions in detail yet, so most of these variables, they are actually used directly inside the functions. So they have utilities mostly inside the functions. But I wanted to show you the exact meaning of these variables. That's why I have just made some public contract variables, so that we can see them here after deployment and know the importance of these variables. So let's go ahead and compile this. You can see there's a green tick available. So all of these, all this are fine. Now let me deploy it. So the moment I deploy it, you see we have received so many buttons. So these, because we have made all these contract variables to be public, so all these values which is stored here is made public to us. Again, I'm focusing on the point that this is not the whole purpose of global variables is defeated if you have to save them to the state variables. But this is only to show this utility to you. Most of the times you will be using it inside the functions. So first, let's see the block number. If I click here, you see that 8 has been returned. That means 8 is the block number on which the current block number on which we are there. Then gas limit. So this is the value of the gas limit of the current block. Again, origin. Now you can see the originator of the transaction. So this is the address, and again I want to click on the owner, and you will see the same address. So the owner is the message dot sender, as I've told you. So the message dot sender who has called this contract. If you will check here, the address of the account which we used to deploy this contract was starting with 5b3, 0x5b3, and that is the same address which is returned by both these functions, which is the message dot sender, which is known as the owner, and the transaction dot origin, which is the origin. So what is the difference between the two? There is a very important difference which we tend to ignore, and that is that, as I told you in my previous lesson also, that a transaction can only be originated by an EOA, meaning externally owned account. So no contract, no smart contract, code based smart contract can ever start a transaction, but the contract can be deployed by another contract. That's possible. So message dot sender essentially tells you that who has deployed the contract. So message dot sender can be a contract also. So the address of the message dot sender, this address can belong to a externally owned account, a person, a wallet address, or it can also belong to a smart contract address. But the transaction.origin will always and always belong to a wallet address or an externally owned account, and never a smart contract address. So that's the difference. And it's always recommended to use message.sender because it gives you the flexibility to interact with the smart contract as well as the wallet addresses. So it's always a best practice whenever you want to see the initiator of this function or this contract, better to use message.sender global variable. Again, if I click on timestamp, so this is the timestamp. You can see this is a numerical number. This is the current timestamp. So if you go in the epochs converter and you put this timestamp, it will show you today's date and time. So this is the number of seconds which we have passed since that epoch time. So so this is it for this timestamp variable. So that is it. Again, these are the global variables. There are many more global variables. You can refer to the whole list at the Solidity official website, and with all the new versions, the syntax and the other some other global variables keep on getting introduced. So we need to be updated with all of them. But these are the most frequently used global variables which we have discussed today. So see you in the next lesson.